Hello, welcome to MapLibre tutorial number 8. In this video, I'm going to show you how to visualize Google Earth Engine data in 3D with MapLibre and LeafMap. So Google Earth Engine is a cloud computing platform that has a lot of geospatial data with over 100 petabytes. I created a Gmap package that can help you visualize the Google Earth Engine data, but it's only for 2D. And so this video, I'm going to show you how you can actually overlay some of the Google Engine data layers on the street terrain. And you can, so in the last couple videos, I already show you how to just use LeafMap and MapLibre to create 3Ds, but this is all coming from not really Google Engine data. And Google Engine has a lot of satellite data that will be very useful sometimes if you pull some data from the cloud without having to post the data on your own. And so we are going to use this novel example. So go to LeafMap website and then scroll down here to find Google Engine. So you can run this one on Google Colab, or you can download this one on local computer on it. And I already have that on my local computer on it. So let me start my Jupyter Lab. I can show you that on my I have all the notebooks. I'm going to find Google Engine, find this one, and a little bit better. And so this one shows you basically the what it looks like. You can also visualize that on directly on my demo website. So go to overview and then here preview the examples. You scroll down to find Google Engine. So I have two examples here. The first one, this one is just the 3D terrain. So we have the uh, ESA lane cover overlay on top of this one. So it looks pretty cool. You can. This is at the global scale. So this lane cover dataset is 10-meter resolution. It's overlay on top of the 3D terrain. Not just the terrain, basically the 3D satellite. The satellite image overlay on top of the terrain. So it's really cool. And this is one. The second one, similarly, but we have also can overlay the 3D view of the land cover. So it's even cooler. You can look at it for any location around the globe because all the data sets are at the global scale. So you're welcome to customize this one to your liking. And this is what this video is going to show you how to do that step by step. So move this one here and let's get started. So this one, so it take too much space. The source code looks a lot, but I'm going to show you how you can easily simplify it. So first we're going to import the libraries, then we can use the leaf map add e layer function. So this function allows you to add Earth engine data layer. So let me run this one, show you what it looks like, right? Pretty cool, and it's very fast. But the add e data layer, the SID, you can just pass in. So if you want to use Google Engine, you can go to the Google Engine website and all the data sets in here. So this is for cloud computing. You do need to know how it works, but I'm going to show you here. So all the data set actually coming from here. So you view the data set, and then from here you can search, for example, ESA or cover. You should be able to find it. CBR, and they have two versions. So this is 200, and the SSID is actually this one. So coming from here, but you do need to this one. You don't need a Google Engine account because I already have a subset of those on my GitHub repository. So it's this ID in here, and the reason for that is I have a URL here generated from the SID. So this is basically the XYZ type URL that we can use to load the map. So when we load the map, we actually use this one, basically the XYZ tile. That's why you can use it. You can also change it to other data set if you want to. So this is at the global scale, and it's adding the layer, and we also have the opacity to just 50%, and then we add the legend. So add the legend, basically the one at the low right in here. So this is the legend that we just added, and we just use the built-in. So LeafMap had the built-in legend, so you have to provide basically all the parameters. So it's pretty easy. And lastly, we add the layer control. So that's why you can turn this one on and off, and pretty easy. So you can zoom in, can zoom out, and navigate to any location. Like I said, you can customize this one. So you can customize location, customize Also, for example, if you want to be fully opaque, then you change to one again. So now you cannot really see. It's still 3D, but you cannot be see because it's not transparent. So it doesn't look as good as what we see earlier. So you want to have some satellite images overlaid top. So this way you can clearly see, right? If you're trying to look at the main cover classification, you can see it is good one or not. Airport, clearly see the roll is all the red color because it's the build up area. And so this is what's one simple example. Again, and customize it to other locations, other files. So here, if I have some 3D the states and also in the US, for example, or you have if the global one, or I can use the 10-meter resolution for the entire US. I can zoom into this one, and then I can just replace this here, and but the laser doesn't show you right. Right now, this is just the DM 10-meter DM overlay on top, and it still looks pretty cool, right? So it's 2D, but we are overlay on top of the DM. So now we can actually zoom in. You can see the 3D terrain because the resolution is not super high, so why very clear, but it's good enough. So the resolution is 10-meter resolution, pretty decent, and because it already has a customized color, so that's why see the white color is high elevation. So I also have green, blue color is lower elevation. Still really cool compared to use just a traditional 2D mapping made without a 3D. Then doesn't look as stunning. Okay, so again, this is just only a subset of data set. And next, let me show you how you can actually customize it. So we can also add a 3D. This is actually the 3D mapping video, but actually now it's so much easier. Actually, we can let me run it first, right? So show you. This is the lane cover. Again, the ESA lane cover, and then we also have the 3D buildings on top of that. And you can turn the layer on and off, right? So we also have the satellite beneath it, show you the location. And so what we can do here, let me simplify this one a lot. Here, layer control that. And so you can actually simply just add 3D buildings, just one line of code. So it should be so much easier. Those things can be greatly simplified. So what we have in here, essentially is just a couple lines of code. So 5 lines of code. We create a map using the 3D terrain. We add the E data layer using the list of available ID that I put in here. And then we add the legend to the lower right corner. Add the layer control is this one. Lastly, we add the layer building. Pretty much that's it. So now we can clearly see really cool. This is New York City, but you can zoom in another location. How cool is this? You can basically overlay all kind of data layers together. So you can have a mix of data from MapTiler. You can have data from other XYZ based map services. You can also have data from Google Sensing. So you combine, basically have access to tons of geospatial data um, liking. So, and again, this is only a small subset, but if you have a Google Sensing account, you can actually initialize and you can actually use any dataset directly from Google Sensing. So in that way, you can access to the entire data catalog in here. So petabyte, petabyte data, you can access it. So what you need to do here, this one does require Google Sensing account. So if you don't have one, you will need follow the instruction here to sign up and get an account. So for me, I already have that, so I can just use initialize, and then I'm going to use my project. So for example, here, initialize Google Engine. Hopefully it works. And then you can uncomment this one. So the source code looks pretty much the same as this portion in here, but it's a lot more simplified. Um, so we're going to directly use Google Engine. So everything, the source code here is the same, except these couple lines. So these 3 lines are different. Right now, instead of using the XY type URL that I created, we are directly accessing Google Engine. So the example, you can look at the example of this one, right? So it's a image collection, and then we do the visualization, and then we add the data layer. You can do the same thing here in leaf map. So we're just going to add the E data layer, but now this one is a Google Sensing dataset. It's not a tile layer anymore. And so this add layer is very much similar to the Gmap add layer function. So dataset visualization, give a name and an opacity, and these two are the same. So let's see if it works. Hopefully, yes. So it works the same way. Looks super cool, right? So now this data layer is actually Google Engine data layer. No, it's still a Thai URL, but as I said, we are accessing Google Engine data layer directly. So if you want, you can access any pretty much any data layer Google Engine. So let me show you another example. We may want to, for example, look at the NLCD link cover, the National Link Cover Database. It's a bit slow, but let me start here. First engine NLCD. Okay, and we have NLCD 2021, for example. It internet down, a little bit slow, but let's wait a couple of seconds. Still loading. I saw it may be just the Google Engine website. Anyway, doesn't work. You can still use this example. You can customize. So what you need to do is to basically load any dataset that you like, and then just add data layer. But this one here, make sure that you understand the differences. So earlier, you will use the asset ID. So this one doesn't require Google Engine. But if you're passing an Earth Engine object and then also the visualization parameters, then you do need a Google Engine account. Otherwise, it won't work. Okay, it looks like it works now. And so you can see here, this is where it actually shows you how to access that. So if you're trying to access this data set, I can just copy this one and then get another one here. So for example, this would be dataset 2. And then we are going to actually, where is it? Check 2021. And filter it to 2021. You can just copy the line by line. It should work just fine. Dataset 2 and filter. Then we get the 2021 dataset. And the last step is that you want to get the lane cover layer here and lane cover. So now this is a Google Engine dataset. So what we can do here is pretty much similar to this one. And so we're going to aim at this one. The visualization, right now we use this lane cover dataset, right? Visualization, we don't need to pass anything. We default one. Then this one we will say NLCD. Let's see if it works. See, it works. And let me turn up this one. So right now we are seeing using the NLCD lane cover. Pretty cool. So this one is the 30-meter resolution. Actually, it's a little bit close, but you can clearly see, right? Lane cover and overlay on top of that. So if you need to be more opaque, we can change it to maybe 0.8 and then realize that. One of the see. Now we are basically overlaying the NLCD lane cover dataset on 3D. Of course, the resolution is not high enough, so it doesn't look very good, but at least you can see this in. Basically, right now, you can load any Google Engine dataset and overlay on top of a 3D frame. So it's so much cooler than just visualizing using app and just. So you're welcome to explore the Google Engine data catalog. There also are tons of other high resolution data. For example, the USD and NAP imagery may have multiple time periods. You can pretty much overlay any Google Engine data layer. All we need is just this example. So certainly I can also add the legend. So for example, copy this one, come here and then build in NLCD or uppercase. The link cover, run again. Cool. So now I have these two layers, right? So the ESA link cover and also the NLCD link cover. Of course, it's just too much. So you might need to hide the link cover and then so LCD link cover here. So now we can visualize that. Okay, so this is how you can visualize Google Engine data in 3D. So it opens a lot of potentials for you to combine multiple data sources together. And especially Google's engine, because the data catalog is so huge, it's over 100 petabyte. Now it provide you a way to visualize data in 3D, massive data in 3D, combining cloud computing, so 3D visualization with Steve Map. I hope you enjoyed this one. I will see you in the next video. Take care. Bye bye.